If the universe were a book, every time we turn a page, we would tremble more in anticipation of what's to come. Why does humanity feel increasingly uneasy as we gain more knowledge about the universe? We once believed that knowledge would bring peace of mind. But what happens when what we discover is an irreparable crack in our understanding? A cold truth that humanity is just a tiny speck in the vast ocean of time. From the collisions of black holes that cause space-time to ripple like the surface of water, to the dream of exceeding the speed of light, the universe is not only beautiful, it's also full of threats. Everything we once believed in, from linear time to the concept of a center of the universe, has dissolved with each new discovery. If you have ever looked up at the sky and asked yourself, where exactly are we standing in this endless silence? Then this article is for you. Telescopes, stay with me until the end, because perhaps, while gazing at the stars, you will encounter the smallness and the wonder of humankind. And if you find something in this article that makes you ponder, don't hesitate to share it with someone you think is also searching for a quiet corner in this chaotic universe. Gravitational waves. When space speaks. Imagine standing in the middle of an endless ocean, still as can be. Suddenly, a stone is thrown from thousands of miles away, creating ripples that travel across the water and reach where you stand. This invisible wave causes the surface of the ocean to ripple. This is the nature of gravitational waves. Tiny oscillations that ripple through the fabric of space-time, and they are happening around us every second. Gravitational waves were one of the boldest predictions of Albert Einstein's general theory of relativity in 1916. According to the theory, any massive object that accelerates distorts space-time and generates ripples that propagate across the universe at the speed of light. However, it wasn't until a century later that humanity heard the first sound of them. The iconic event, GW 150914, on September 14, 2015, the Laser Interferometer Gravitational Wave Observatory LIGO detected the GW 150914 event, one of the greatest scientific discoveries of the 21st century. Two black holes, with masses of 29 and 36 times the mass of the Sun, collided 1.3 billion light-years away, creating a new black hole and emitting a powerful gravitational wave. What was astonishing is that the total mass of the black hole formed after the collision was only about 62 times the mass of the Sun. The missing part, about 3 suns, was entirely converted into energy in the form of gravitational waves. In that brief moment, the energy released was greater than the combined light of the entire universe. Space is no longer silent. Gravitational waves allow us to hear cosmic phenomena that were previously only speculated by theory. If light is the eye of traditional astronomy, then gravitational waves are the ears of the new generation of astronomy. Thanks to them, we can detect black hole collisions, neutron star mergers, and even the echoes of the Big Bang, the sound from the dawn of time. A significant milestone was the GW 170817 event, the first time both gravitational waves and light were detected from the same neutron star merger, heralding a new era of multi-messenger astronomy. Since then, scientists not only know when and where an event occurred, but they also understand the underlying physical principles, opening up a new chapter in our understanding of the universe. We live in a universe we can listen to. What's remarkable is that these waves are incredibly tiny. They change the length of a 1,000-meter-long object by the thickness of an atom. To detect them, scientists had to build laser interferometers with precision far beyond any technical standards ever before. This makes LIGO and Virgo some of humanity's technological marvels. From the faint echoes in space-time, we are now beginning to map the universe, not by color, but by frequency. The death of stars, supernovae, and the legacy of light. The death of a star is not the end. On the contrary, in its death, it leaves behind the brightest light in the universe. Supernova explosions that can illuminate an entire galaxy. But what's even more haunting is that very death is the beginning of everything, including us. How do stars die? A star is like a gigantic nuclear fusion reactor. For millions to billions of years, it burns hydrogen to create helium and heavier elements, emitting light and radiation. However, no fuel burns forever. When the core of a star can no longer generate enough energy to counteract its own immense gravity, it collapses. For stars with a mass greater than 8 times the mass of the Sun, this collapse triggers a supernova explosion, releasing an immense amount of energy in just a few seconds. In that instant, the energy emitted by a star can surpass the combined energy of all the other stars in its galaxy. The legacy of light and elements. What's astonishing is that most of the heavier elements, like iron in our blood, calcium in our bones, and gold in wedding rings, do not form in the stable cores of stars, but only emerge in supernova explosions. The phrase, "we are made of stardust," is no longer a poetic image. It's a scientific fact. These explosions create shockwaves that collapse the surrounding gas clouds, forming new generations of stars. A continuous cycle of life and death, constantly being recreated in the universe. Looking back in history through the light of death. Some supernovae have been recorded since ancient times. For example, SN 1054, which was documented by Chinese astronomers, was so bright it could be seen during the day, leaving behind the Crab Nebula, which we still observe today. Today, with modern telescopes like Hubble or James Webb, we not only see these remnants, but we also witness them at various stages of death, as though we're watching a light memory replayed from millions of years ago. When death becomes the beginning, some supernovae leave behind even more bizarre objects. Neutron stars, stars with the mass of the Sun but only the size of a city, and black holes where nothing can escape, not even light. These objects continue to influence their surroundings, pulling in gas, bending space, and emitting gravitational waves. In the universe, death is never the end. It's the first chapter of countless new cycles. Black holes, invisible monsters at the heart of galaxies. If there's anything that fascinates and terrifies scientists in the universe, it's black holes. These strange entities emit no light, reflect no signals, and suck in all matter, even time, toward them. What is a black hole? A black hole is a region of space-time where gravity is so intense that nothing can escape, not even light. It forms when a massive star collapses completely after a supernova explosion. All the matter shrinks into an incredibly small point, known as a singularity, where all current physical laws become meaningless. Surrounding the singularity is the event horizon, a boundary from which there is no return. Any object crossing this boundary disappears forever from the observable universe. How many types of black holes are there? Astronomers classify black holes into 3 main categories. Stellar mass black holes. These form from the death of large stars, with masses of a few to tens of times that of the Sun. Intermediate mass black holes. These are larger, ranging from a few hundred to a few thousand times the mass of the Sun. They are still quite rare and were only confirmed recently. Supermassive black holes. These reside at the centers of most galaxies, including our own Milky Way, with masses ranging from millions to billions of times the Sun's mass. A prime example is Sagittarius A*, the black hole at the center of the Milky Way. How do we see black holes? Because black holes do not emit light, we cannot observe them in the traditional way. Instead, we detect them through their effects on the surrounding environment. When a black hole pulls in matter, the surrounding accretion disk gets heated to millions of degrees and emits extremely strong X-rays. Disturbances in the orbital motions of nearby stars also reveal the presence of an invisible and extremely heavy object. The pinnacle of observational technology was the first image of the shadowed region of the M87* black hole, published in 2019, from data gathered by the Event Horizon Telescope, EHT. Why should we care? Not only are black holes gravity monsters, but they also challenge the limits of physics. Here, Einstein's theory of relativity and quantum mechanics, 2 pillars of modern physics, contradict each other. Thus, black holes may be the key to a unified theory of the universe, something humanity has been pursuing for centuries. Additionally, black hole mergers, when 2 black holes collide, are the source of the gravitational waves we first began hearing in 2015. Beneath the ice, the oceans of life hidden on distant moons. When it comes to the possibility of extraterrestrial life, most of us tend to look toward distant planets, those with atmospheres, light, and temperate conditions. However, scientists are increasingly convinced that life may be hiding beneath the icy moons within our solar system, where there is no light, but liquid water and energy sources. Europa, the gem of Jupiter. Europa is one of Jupiter's 4 largest moons. Its surface is covered by thick ice, but beneath it lies a global ocean, containing more water than all of Earth's oceans combined. What signs make scientists believe there is an ocean beneath? Cracks and flow patterns on the surface suggest that the outer ice layer is floating on a liquid beneath. The Galileo spacecraft once measured an anomalous magnetic field, a sign that there might be a conductive layer below, possibly liquid saltwater. In 2016, the Hubble Space Telescope detected water plumes erupting 200 kilometers high from Europa's surface, similar to the geysers found at Antarctica. Enceladus, Saturn's water moon. Another intriguing candidate is Enceladus, Saturn's icy moon. The Cassini spacecraft flew by Enceladus several times and discovered water plumes erupting from the tiger stripes on its surface, spewing a mix of water, hydrogen, and organic compounds. Beneath the ice shell, about 20 to 30 kilometers thick, there's a liquid ocean covering the entire moon. There's potentially tidal heating from Saturn's gravitational pull, which keeps the water from freezing. What's particularly exciting is that the hydrogen molecules discovered could suggest biological reactions similar to those at Earth's deep ocean vents, where bacteria live off energy from hydrothermal vents without needing sunlight. Why are subsurface oceans important? In the harsh conditions of the universe, liquid water plus heat energy plus organic molecules equals the formula for life. Europa and Enceladus have all 3 of these elements. If life exists, it could be developing in very different ways, without light, without an atmosphere, and that would be a revolution for both biology and human philosophy. In fact, some scientists even suggest that life on Earth may have started in a similar way, at the bottom of the ocean, rather than on the surface. Exceeding the speed of light, dreams, hypotheses, and the ultimate limits of physics. In every science fiction story, from Star Trek to Interstellar, there is one common theme: humans have surpassed the speed of light. But is that physically possible? The speed of light, an unbreachable limit? According to Einstein's theory of special relativity, no object with mass can reach, let alone exceed, the speed of light, approximately 299,792,458 meters per second in a vacuum. Here's why. As an object's speed approaches the speed of light, its relativistic mass increases. This requires infinite energy to reach the speed of light itself, which is physically impossible. So why do we still dream of surpassing this limit? Because the dream of exploring the vastness of the universe can't wait thousands of years to reach the nearest star outside our solar system. The hypothetical solution: warp drive and the Alcubierre engine. Miguel Alcubierre, a Mexican physicist, proposed a theoretical model in 1994 known as the Alcubierre drive. The idea: instead of moving a ship faster than light, warp the fabric of spacetime around it. A spacetime bubble is created. The space in front contracts while the space behind expands. The ship doesn't move through space, but space itself moves around the ship. This would theoretically allow for faster-than-light travel without violating relativity. But there's a major problem. This model requires negative energy or exotic matter, negative energy density, which has never been found or created in the necessary quantities. It may also violate energy laws in quantum physics. Wormholes, shortcuts through spacetime. Another concept emerging from general relativity: wormholes, a tunnel that connects 2 different points in spacetime. Imagine folding a piece of paper and poking a hole through it. That's a wormhole. If a wormhole could be stabilized using exotic matter, you could travel from the solar system to the Andromeda galaxy in just a few seconds. But there is no evidence that wormholes exist. Even if they did, they could collapse before a photon could travel through them. More practical projects. Although the above hypotheses are far-fetched, there are projects like Breakthrough Starshot, sending ultra-small probes to Proxima Centauri at 20% the speed of light. NASA Eagleworks, researching new physical effects that could open the door to warp drive. Although the results are still in their early stages, the dream of warp may not always remain fiction. Summary viewpoint: exceeding the speed of light is not just a technical issue. It's a matter of philosophy and fundamental physics. Looking up at the sky, why, as the universe expands, do humans feel more anxious? Since the dawn of time, before telescopes or laws of physics, our ancestors looked up at the sky to find answers about life, death, and the meaning of existence. But today, knowing that we are just a speck among trillions of galaxies, this doesn't provide comfort. It creates a profound sense of unease. Why is that? The absolute smallness of humanity. The observable universe has a diameter of about 93 billion light-years. In this vast space, our planet is just a tiny speck, orbiting an average star in a common galaxy. When confronted with this scale, everything that once seemed important, success, money, fame, becomes meaningless. This cold reality forces us to ask, if everything is so small and fleeting, what is the purpose of our existence? The death of everything, even the universe. The sun will run out of fuel in 5 billion years. Stars will extinguish. Galaxies will drift farther apart. Eventually, the universe will experience heat death, an infinite, cold, lightless, and motionless void. Science does not promise a paradise. It only reveals a cold end, where life is the exception, not the rule. The more we know, the more we see the contradictions. The more we understand about how the universe works, the more we realize that there's no special place for meaning. Nature does not care who you are. It doesn't need you to be happy or in pain. This is the existential shock that many people experience when confronted with modern astronomical knowledge. We are not special, or perhaps we are very special. Perhaps life is common, and we are just one point in a sea of millions of identical points. But maybe we are unique, the product of an incredibly rare chain of random events. Both possibilities are terrifying. One side is the meaninglessness of repetition, the other is the absolute loneliness. So what should we do? Understand our smallness, but not our meaninglessness. Understanding the universe does not diminish human value. On the contrary, it emphasizes that, amidst the chaos and meaninglessness, we are the only creatures who seek meaning. It is the act of observation, exploration, and love that makes us light in an otherwise cold universe. The faith in science, not to escape fear, but to face it. The universe doesn't need us to understand it, but we still choose to seek the truth. That is the pride and courage of human intellect. We are alone in the universe, but we are not isolated. Because every time you look up at the sky, there are millions of others quietly looking up with you.